Hello and welcome to this presentation of ConfigFix, an interactive configuration conflict resolution for the Linux kernel. The Linux kernel. Today, it's the largest software development project in the world with roughly 30 million lines of code. It's not just big, but it's also highly configurable, with roughly 15,000 configuration options, which are also called features at times. Even though it was not originally intended, but today the Linux kernel runs on a variety of devices, anything from a computer to a smartphone, a TV, or a network device. But wherever you use the Linux kernel, you will only be using a small part of its functionality. So there's obviously a need to be able to configure the kernel for a specific purpose. The kernel offers a number of different configurators. There are command line options and there are options with a graphical user interface, like this one, which is called Kconfig. Now, depending on how you configure your different options, you can customize the kernel for different purposes. However, there is a small problem, namely that configuring the kernel can be hard. A study found out that enabling a disabled option can be quite difficult. And this is not just for newcomers, but also for experienced developers who sometimes need a lot of time to resolve these situations. If we take a look at this example here, we have an option which we would like to configure. However, we cannot configure it at the moment. And if we look at the info text, it is not immediately obvious why we cannot configure it or what we would need to do in order to configure it. The reason for this is that the Linux kernel lacks an intelligent reasoner who could aid the user in resolving these situations. That of course begs the question, is it really that difficult to implement an intelligent reasoner into the Linux kernel? The answer is yes, it is. But why is that? Let's start with Kconfig. Kconfig is a variability modeling language which was developed specifically to describe the kernel's variability. The options in Kconfig are organized in a tree structure, which for example means that every option is dependent on its parent. However, the syntax and semantics of Kconfig are quite intricate, and this goes well beyond propositional logic. For example, there are 5 different types for each option you could choose from. Kconfig uses a 3-state logic. There are various forms of dependencies. For example, if we wanted to enable the red option, we would need to enable all the orange options as well. There can be visibility restrictions, meaning you could make an entire subtree invisible while still allowing the options to be configured implicitly. And finally, we also have default values and ranges. This is a short example of how Kconfig actually looks. You can see that we can define the name, a type, dependencies, a default value, and a help text. Now a bit about the history. In 2010, the semantics of Kconfig were formalized for the first time. And based on this formalization, academia has developed various tools to deal with config. For example, that one could parse Kconfig correctly, one could translate Kconfig into propositional logic, and even resolve configuration conflicts with the help of this. But as far as we know, none of these tools are currently implemented in the kernel. So we think it's important that we give something back to the kernel community. Now, before we started with this project, there were some challenges and requirements. The community has a strong preference for SAT solvers, compared to, for example, SMT solvers. But in order to do that, we need a propositional abstraction of Kconfig. However, due to the properties of Kconfig, no such abstraction could ever be fully sound, which means there are always cases which cannot be modeled accurately in propositional logic. As for the formal requirements, the implementation should be C-based, so that we can use the existing infrastructure of the kernel, and that the tool could be used by any configurator. We would also need to find and implement a compatible SAT solver. compatible in both the language and the license. Combining this with the previously mentioned tools, we developed our tool ConfigFix. Now, here you can see a high-level overview of our tool, what it does. We usually start by creating a semantic abstraction of the Kconfig model into propositional logic, and we then translate this into conjunctive normal form such that it can be used by a SAT solver. We combine this with our configuration goal, that is what we want to change, and we then use a conflict resolution algorithm called RangeFix to create a valid configuration which takes the configuration goals into account. And how does that look in practice? We based our implementation on Kconfig, which was shown previously, and added this bottom panel. On the left side, you can define the different options and how you would like to change them. And on the right side, you will be presented with different solutions. In this example, we added one option, which is not configurable at the moment. And we say that we want to change its value from no to yes. The tool is then able to find a number of possible fixes. And when we apply this selected solution, we can see, for example, in the top right corner, that the value of this option has changed from no to yes. Of course, we also evaluated our tool, and for this we created a number of different configurations for different architectures. In each example, we try to change between 1 and 10 options, and our tool was able to produce at least one fix in almost 80% of the examples. In those examples, we found fixes which resolved the conflict correctly in about 65% of the cases. We are still improving our tool, and by improving it, these numbers will improve as well. As for the experiences during the course of this project, the toughest challenge was the semantic abstraction of Kconfig into propositional logic. We decided to follow the translation of the Kconfig reader, which is a tool written in Scala. We took this translation and implemented it freely in C directly in the kernel. As for the SAT solver, we decided to use picosat for two reasons. On one hand, picosat satisfies all the formal requirements, and on the other hand, picosat had been implemented successfully in the project called SATconfig. For the GUI integration, we had to make extensive modifications to Kconfig. At the same time, we wanted to follow the interface of other configurators who have support for conflict resolution, for example, ECOS. One issue in all of this was the scalability. Now, with 15,000 options, the kernel has a rather big model, which means that performance of the tool is very crucial. That meant, for example, that we had to deviate from the translation of the Kconfig reader in certain regards in order to gain more performance. Finally, we also had to come up with a way to evaluate our tool, and this required even more modifications to Kconfig. Summarizing all this, we can say that configuring the Linux kernel is hard, but implementing an intelligent reasoner is even harder. If you're interested in trying out this tool or simply want to have a look, don't hesitate to visit our repository. And as a final note, I can say that we're actively working with maintainers to integrate the tool into the kernel mainline. Thank you.
Hello. Hope you enjoyed the Patrick presentation about ConfigFix, his work. Actually, I was impressed, Patrick. I read from your paper and hear from your presentation that this is work from 13 years of academic research. What do you mean? It is 13 years or it is accumulated by the effort that was put in the...
It was accumulated. Over the years, different tools have been developed, and then these tools have been used in other tools. It's not that I had worked on this for 13 years, no. I've worked on this maybe for 2 years or a little over 2 years. But,
yeah, but
it was
still,
usually one thing led to another and then to another and so on.
yeah, so still it's impressive. And by the way, this is a blended session. I didn't say before, the previous paper in the session were from the technical track, and this is from the software engineering in practice track. In fact, it is a very practical and useful result that Patrick presented. So while the audience warms up, I don't know if this is something that I missed from your presentation. So you said that you want to give back to the kernel community with this result. And could you comment how this proposal was received by the kernel community or the?
Well, we haven't sent it back yet. We're in. We have a couple of details to iron out, and then the plan is to send it to the kernel mailing list, so people can actually test it and possibly give feedback.
Okay.
That's the plan. I don't think we're too far away from that, but we have to clean the code up a little and so on.
And you want
fix some small issues.
And probably you want also some feedback from XC audience, right?
Yes.
Okay, we have one question from David. He asks, how problematic is the performance issue of the SAT solver for your guy?
Well, the SAT solving part is what makes the performance. I think the translation and just creating the SAT problem, that is fairly quick, but actually resolving a conflict can take a lot of time, and that is due to the algorithm which can make many calls to the SAT solver. This is basically the bottleneck of the performance, the SAT solving part.
So David probably went straight to one of the main issue that probably you will be working. And what about usability? Do you need to be a deep expert for interacting with the configs, or?
No, I think the user interface is fairly straightforward. You just choose the feature you want and what you want to change it to, and then it's for the user just 2 mouse clicks. So no advanced knowledge needed.
Yes, my question was more about choosing if, I mean, it is easy if you are not a deep expert of what is happening in choosing what to tell in the fixing.
I don't quite understand the question. Or how do you exactly do you mean that?
So when you configure, you need to understand what is going on better, or you could also be not very expert for interacting, not in the friendliness of the interface, but for understanding actually what you are fixing and what you are configuring.
I would say you need some knowledge. I mean, you have to know what you want to change, which feature you want to enable or disable or change. You need to know that. We can't tell you whether it's a good idea to use this fix or not. That is probably a subjective question.
Okay, David is the author of the previous question. Asks thank you for your answer, and ask what is long time for your example, to define long time.
I mean, we have examples which we can resolve in a couple of seconds, but we have also found examples which can take a couple of minutes to resolve. Unfortunately, when we chose our examples, we picked them randomly. So we unfortunately do not know whether this was a really realistic example, how often people would actually choose to change or enable this feature. But yeah, it can take quite some time. if you are unlucky.
Okay. Thank you. David say, okay. I don't see other question for the moment. Something that I ask people while we fill the empty space is what is your next step? So you said you are going to submit the proposal and other plan for future works.
I mean, we try to continue working on it because there are a couple of things that can be improved, like improve the performance or things like that. It's not like when we send it in, the project can be considered absolutely finished. There will probably still be a couple of bugs, certain conflicts that are not resolved right now, and trying to fix those. Yeah, but I would say the priority right now is working on the performance.
Okay, thank you. I don't see other question from the audience. Actually, your presentation was really clear and well done. Congratulations, Patrick. So probably this is why we don't get many other questions from the audience. But by the way, as I said for the other paper, please, when the time expires, we have 2 minutes left. When the time expires, go to the discussion room. And again, for the audience, you can join Patrick and you can make your question with your microphone and your camera set on. Okay. No more questions? Maybe we can just thank you and we can close here. Congratulations again for the work is impressive, really. And see you next ICSI with it implemented, okay, in the kernel. Okay.
Thank you.
So thank you again and enjoy the rest of the conference. Bye-bye.
Bye.